Now, so we are welcome to the class, and then we continue from where we stopped last time. We concluded the presentation on k-nearest neighbor as one of the first set of classifiers to be looked into. So we discussed how it works, some of the intricacies, suggestion on when to use it and how to use it. We also demonstrated the use of k-nearest neighbor in a weaker environment. And we also used the opportunity to briefly describe the procedure, this very simple procedure whereby you can turn the parameter, the hyperparameter of the k-nearest neighbor, majorly the k, the value of k, so which is the most important, then followed by the distance measure that you can try a couple of available ones like the Manhattan, the Chebyshev, the Euclidean distance, and a host of others. However, while stressing that k is virtually the most important of the hyperparameters. So today we are continuing with this series of exposition on classifiers or machine learning algorithms that are often used for either classification or regression, as the case may be. So today we are taking on decision tree, as we can see, decision tree. Decision tree is a very, very important algorithm, very, very important. I personally like to use it, especially if you have clients who are not from computer science field. So it's because you need to carry your client along sometimes so that they can easily understand what you are doing. So decision tree is one of the algorithms that are really very interesting and very simple to implement. And one thing, decision tree is not new. This is another advantage of this method. It's not new. Decision tree has been as old as whatever we can think. They use it regularly for problem solving in engineering, even in businesses, even in your office, even in our daily lives. So when you have options in front of you, you quickly pick your pen and you start drawing. Okay, we are here. Okay, if you do this, okay, this student belongs to class, maybe this is a GSS, junior schools, and this is senior schools. So in the senior school also, you have further breakdown. Okay, this is SS1, this is senior secondary 2, and this is senior secondary 3. In the GSL, we have the junior secondary 1, we have junior secondary 2, and then junior secondary 3. You can see here, we use it on a daily basis. Even when you go to buy some things, you try to break them down. Okay, this one, under this, I have this. This is actually a decision. This is a tree, actually. So decision tree support people is being used a lot in engineering, business-oriented study, and even our day-to-day activities. That's why it's one of the very simple algorithms, apart from few entropy terminologies and the information gain that offer you to decide if I'm here, should I go here or go here? Which of the variables should I use first? Then we need some algorithm to guide us to select the best one that can guarantee better result quickly. Apart from that, decision trees are as simple as what we've been used to, some of us that have used them in our different field of endeavors. And as the name indicates, usually you have a tree with branches. So this is where the name came from. You have tree with branches. So now you invert the tree. You put the tree upside down. You turn the tree upside down so that the tree is now here, and then you have branches pointing down. That is what we mean by decision tree. Now, so here we're going to look at what is the decision tree, how it works, examples, pros and cons. And then we also try to demonstrate how we can also implement it. Now, we say decision tree builds classification or regression models in the form of a tree structure. So which is often referred to as graphical representation. And that is why it's very appealing to many people. See, you have a client, you try to explain what you have done to them. You start talking about support vector machine where you have to solve some quadratic equations, quadratic optimization problem. They start saying, what is quadratic? Where are you going to start? So, but in decision tree, usually people don't have problem convincing their client or explain what they have done to their client, because it's a kind of graphical representation. And anything that is more graphic, then it makes it easier for people to quickly understand in most cases. Now, so it is a graphical representation of possible solutions to a decision based on certain conditions. Possible solution. There are usually so many possibilities in decision tree. This is another thing with it. And that's why decision tree is one of the foremost and the earlier used algorithm for the implementation of ensemble techniques. When you want to have several decision tree are built randomly, and then they can try to take voting from this decision tree. One of them is called random tree, random forest, and so many other versions of decision tree based ensemble, because you can easily create several solutions. If you have like, let's say we have like 50 variables, so one first variable up to 50. If you start your decision tree break down with attribute 1, you are going to end up with a different decision tree. When you start with number 2 first. I'm starting with number 1 here. Here I'm starting with variable 2. I'm going to have another decision tree. I'm starting with variable 3. I'm going to have another decision tree. Even when you start with variable 1 here, the next one here, you decide to pick 5 and 10. I start another one with 1, but the next one was going to be, instead of 5 and 10, I'm starting with 7 and 11. Although I started with the same value, the same variable, I'm going to end up having different trees. That is why you can have several possible solutions from the same problem. And that's why it's a very fertile ground for ensemble. Now, so they say the name decision tree was often given because it starts with a single variable, which then branches off into a number of solutions, just like the tree I've hypothesized earlier. Now, then we look at the component of decision tree. When you want to build a decision tree model, so how does it work? How does the algorithm guide us to build it? So before we look at the practical demonstration here, let's look at some of the main components. The first one is the root node. The root node of a decision tree is the topmost node, so which means it implies the best predictor. See, predictor means independent variable. It's another name for feature. So that you don't be confused. Feature, independent variable. It means a variable that doesn't depend on another variable, because we are using it actually to predict the output. So we also call them sometimes predictors. See? So your model is not a predictor. So I used to see people make this mistake. When they build model, they say we have built a predictor. You don't build a predictor. The features are the predictors. Those are the things that will assist the model to be able to predict what output you want to predict. Now, you can build a prediction model. It means a model that is used for prediction, but that model is not a predictor. So now, so the root node is arguably the best predictor. That is, if you follow some of the standard or guidelines that we're going to mention later. But if you build your tree at random, it doesn't mean the best, the first one, the root node is going to be the best one at that point in time, if you do it randomly. So because there are some algorithms that are used to check which of these predictors, if I choose it at first, maybe I will just take like 2 steps and I'll finish my decision tree and I'll get excellent result. If you mistakenly choose a wrong attribute, you may have to pass through the procedure of breaking down the tree 10 times before you finally finish the model building. So that is why the choice of the predictor to be used first or next is very, very important. We're going to discuss few methods of, or 1 or 2 methods of determining what is the next feature that I should use. However, you can build it at random. Just look at any variable you like, just use it. However, that will not guarantee for you that you are building the best tree. Now, so the root node is the topmost one. So this is why this is going to be an example of a root node. See, we have account balance as one of the variables. We have duration of the credit. We have length of the current employment. We have payment status of previous credit. So these are the attributes, 4 attributes we have there. So we decide to go with this first one. This is the root node, the topmost. So if you use the algorithm to determine the most important variable, then we assume that root node is the best predictor in your attribute pool. So you go for the best. Just like in several systems also, if you have people, you want the best, you want to lead your team as much as possible, because if the best of them is leading your team, maybe you might be able to get solution soonest. So then the next one is the decision or the internal nodes. So these are nodes in which predictors that the independent variables are tested, and each branch represents an outcome of the test. So once you test, we have the root node, you are going to take a test. Is the account balance here, is it less than this? So then we are going to have, okay, the duration of the credit. Should I go here or should I go here? Then we're going to take the decision also. At every node you get to, you have to decide, where do I go next? So now these are called the decision nodes. Then we have the leaf or the terminal nodes. So you can have several decision nodes until you get to terminal. Terminal means, because what you are doing at every node is you are asking the question. See, if the account balance is greater than 3, okay, you put all the samples in this direction. If the account balance is less than or equal to 3, everybody that falls into that condition, you put them here. So you keep going down. Here also you take the decision, the duration of the credits to be that the client is applying for. Is it less than or equal to 30? If yes. If it's greater than 30, you go here. Here is less than or equal to. Why this one is greater than? It means at every point in time, you keep having somebody that will be here. So you can see here, after this point, now we go to the next decision node, the payment status of previous credit. We pick out another attribute. That's okay, what is were you able to pay back your credit the last time you took it? So, okay, we have a decision nodes here. It's either yes or no. So depending on the problem that has been modeled. So at the end of the day, when we have some conditions, either the attribute finished, there's no more attribute to test. So you have everybody has been classified that you're either A or you are A. In that case, no more picking of any other attributes. So we call these ones the terminal nodes. At the terminal nodes, everybody is given what you deserve, or every sample has been successfully classified into where they belong to. So this is the terminal node. It holds a class label or the final classification outcome. That, okay, after we have done this, everyone knows the class that it belongs at a point in time. You can see here, some group of people who are categorized after you pass this test here. Your account balance is less than or equal to 3. That 3,000 depends on 3 million. So it's up to the model, we model and the data. So here you have greater than 30. So all people that fall into greater than 30, at this point, they are all classified. They are satisfied. However, less than or equal to 30, we still have some mixed mode there. See, they don't satisfy this condition. They might still be part of this class of this guy, but they have some issues. So we go here and then use their payment status to categorize them once again. After using this, all of them are finally classified. There's no more mixture of samples. It means at the terminal nodes, you have only one type of class. So everybody here is going to belong to maybe class 1. Everyone here might be class 1 or class 2. So, but you don't have mixed one. Anywhere you have mixed one, you have to bring an attribute to separate them into 2 as you move on the ladder. These are the components of decision tree. We have the root node, decision or internal node, and the leaf or terminal nodes, which contain the class that you have assigned to. Now, decision tree have majorly, of course, two types. So we have the classification and the regression tree. Classification is the most popular one where you use it. So it is considered the default kind of decision tree. You can see it's the default. So we used to separate the data set into different classes based on the targets. So we do that when the target is categorical. That is, categorical means yes or no, male or female, pass exam or didn't pass exam. It could be multiple also of classes, depending on the problem being modeled. They also have the regression tree, whereby the target variable is a continuous or numerical type. So for example, I want to predict the score of a student in an exam. So here we are going to use regression tree. So now, it must be noted that even though decision tree has this capability, we see later some of the challenges that could also come with regression. That's why it's often used majorly for classification. However, it has the capability to also handle regression problems. Now, let's look at an example. So let's say we have this kind of data. So we want to classify the data. So you'll be given the training set as usual. You use the training set to build the model. So this is a class label training tuple from an all electronic customer database. Now you have the ID. This is not part of you have to take note of that. Once you get the data set, it's not all attributes that you're going to take note of. Some attributes are just there to identify the samples. So this is an ID, 1, 2, 3, 4. You don't use it as an attribute. So it's out of the attribute, okay? Just to identify. The first attribute here is age. So the age, you can see here, it has values like, it is not a numerical value. So it has youth, middle age, senior. I think those are you have to note, okay, these are the number available. Income, high income, medium income, and low income. Student, that is the category. Is the person, is he a student? No, it's not a student. Yes, he's a student. Credit rating, fair. He has a fair credit rating. That is the previous credits as he been repaying by at the normal time. Excellent. These are the values you have in this kind of, these are categorical values. So you are assigned at certain values you can give. Now, the class that we want to predict is actually the person should he buy computer or not. So these are historical data of what really took place. You can see this person with this attribute. No, he didn't buy a computer. This one with this attribute. This one bought it. So what is needed? So you want to predict if somebody should buy a computer or should not buy a computer. So they are going to give you, once you train your model, they will give you the value for my age, income, student, credit rating. Then your system can predict if it's okay to buy it or not to buy it. Now, this is an example of the training data. So when you are given this kind of training data, it can be any other thing. Just like even it could be number. You are going to see later also, we're going to do example of number. It could be number. The age could be here, where you have, okay, 20 years, 70 years. Then, but you have to do the work yourself now. You have to do binding, in which case you have to say, okay, I'm going to deal with if the age is greater than 70 or the age is less than or equal to 70. So we group them together. This is one of the procedures we are going to discuss. So this is an example of training data set that we want to use for our decision tree. Now, let's take, for example, now we assume. So we assume that we're starting with the age, because we can pick anyone at random. You can start with income, you can start with student, you can start with credit rating, you can start with age. But the idea is we want to pick the attribute that will make us to finish our classification quickly and will give us higher or better results. So that's why we're going to discuss how you can detect. You don't just choose them at random. Let's say you want to build a random ensemble, random decision tree. So in which case you choose this one to be the beginning, next one you choose this one, next one you choose this one, then you made them vote after the combination of several decision trees. However, if you want to build only one decision tree, then you need to pay attention to which of the attribute am I going to select first. We check the entropy, which attribute will give us quick classification and accurate classification. Now, but for now, let us assume, okay, we're starting with age. So when you pick the age, see, if you look at the age, the number of values that these attributes has will determine the number of this particular flowing outline that will be drawn for it. So if you go back to the data, you see that age has youth, middle age, that is second one, and senior. That is only 3. Yeah. So you are going to create those nodes there. So age, you have youth, you have middle age, then you have senior. Then you are going to look at it. So you start categorizing the samples. Is your age youth? So everybody that has youth here will be pushed to the left side. This one has youth, 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 youth. So the same thing for middle age. See, then the same thing for senior, credit rating. See, sorry, for the senior, this one senior is here. We put everybody as senior here. Now, something happened here. This is what we are looking for. Just after selecting for middle age, you have years. The implication is, if you start with age as your first attribute for this decision tree, then it means that all samples that has middle age, they are categorized as years. They're going to buy computer. So we love this kind of decision tree actually. Actually, this is what we are looking for. It means age is a good attribute because just one step, we were able to categorize everybody that is middle-aged based on age is yes. And you can go back and see it. Anybody that is middle-aged, this is middle-aged, you can see here, it is yes. Middle age is yes. Middle age is yes. It means anybody with the attribute value under age to be middle-aged, it's automatically yes. It means we are done with the classification of samples. So it means whatever the income of this guy, is that the income is high or is he a student or not, it doesn't matter anymore. We are done with it. That is why you can see here, we just put a middle age. The next thing is terminal node. This is terminal node. Terminal node. When you have this kind of terminal node, it means everybody, every sample that has middle age as the attribute value for age, they are all categorized into years. So we are done with that. And this is what we are looking for. If you try to use credit rating as the first one to start with, you see that you'll not be able to get quickly to complete one. And what we are looking for always is we want the attribute that when we select it, we can quickly categorize several samples at once. By the time we do the second one, then we'll be done. Now, so here now, we don't need to select any attribute because everybody that has middle age, they are all yes. Middle age attribute under the age, they belongs to middle age category. They all bought computer, yes. However, we have problem with people whose age is reading youth. It means here we still have some people who are youth, and we have some people here who are youth. So we have people also here, these are the seniors. But the middle age group, they are the one that we totally categorize them at once. Now, so the next thing is to move back again, then you are going to select the next attribute. Now, the attribute that to come is student. We are going to tell you why don't we choose income. Like I said, we are just taking a kind of random one at the beginning or based on the knowledge of the developer. But we explain to ourselves how you can use a very simple procedure to determine which attribute should you go for next. Now, so when we go, we now choose students. So we now check, are you students? He said no. See, that is everybody that has under age, he has youth. Under age, he has youth. You see here, the age is youth. But because this is youth, this is no. You can see some youth here, yes. So that is why we did not conclude that particular node. We don't have a terminal node yet. Because a youth, there are some youths who bought computer and there are some who did not buy computer. So that's why we need another attribute to help us split them into two. So some youths are either yes or no. So when you have such a case, we need another attribute to help us break them down, because we want a terminal node that anybody on the left, all of you belong to the same class. On the right, you belong to the same class. At that point, we stop. But if we cannot able to do that, no, we still continue to break it down. The same thing goes for senior here. You see, it means some people are senior that are either buying computer or not buying computer. So we need credit rating to be able to separate them at a point in time. You are going to see. See, you can see some senior here. They didn't buy computer. Look at another senior, he bought computer. So that's why we need to use, in that particular direction of decision tree, we need to use another attribute to separate them. However, for the middle-aged, there's no single person that is middle-aged and does not buy computer. This is how we know that at that point, we reach the terminal node quickly from people that are middle-aged. Now, this is how we do the decision tree. So here now we look at people with youth, yes or no, then we now put student there. Are you students? Yes. If you are a student, you can see once you say no, you are not a student, automatically you don't buy computer. Student, yes, automatically you buy computer. If you go back and look at it, you see that anybody that is youth and not a student, they didn't buy computer. You can see youth, not a student, no computer. Youth, not a student, no computer. But whenever you have youth, not a student, no computer. But youth, yes, you are a student, buy computer. Youth, you are a student, you bought computer. This is the basis upon which we arrive at the terminal node at this point. That is a decision tree. For the senior also, you do the same thing. We check their sins. After going to the seniors, checking the senior people in terms of age, some of them are yes, some of them are no, even though they are senior. So we now look at, okay, credit rating. Can the credit rating help us check? We see that, okay, with senior, we can see. Somebody will ask, for senior, this is based on experience, person developing decision tree. We can also repeat student here to check. However, from senior, if you go for student as the attribute to divide there, you take longer time to reach the terminal node. That is why after every breakage, you have to calculate the entropy to know, okay, what is the next thing that I should select? What is the next thing that I should select to break it down? Because we want to minimize the number of iterations that you are going to do. Now, next, this is a short description of what we're trying to explain to us, the classification by decision tree induction. The procedure used in decision tree is known as decision tree induction. So, decision tree is a flowchart-like tree structure with internal node that denote a test on an attribute. The branch represents an outcome of the test, and the leaf node represents class label or class distribution, as the case may be. Now, decision tree generation consists of two phases. So the first phase is the tree construction, whereas we start at the training set. So at the beginning, at the root node, all the training examples are the root node. Then we partition the example recursively based on selected attributes. So we select one attribute, we push you to left or right. If we find out that at a particular node, all the members of that node, they belong to the same class, then that node you stop. You don't need to do anything because you finish your classification. That was what we refer to as the terminal node. Anybody that has middle-aged, after the age attribute is considered, they all belongs to yes. So we are done with anybody with middle age. So those samples can be removed. We now focus on those samples that are having youth and senior. This is how we solve it until we are able to categorize all of them. Then sometimes we do what we call tree pruning. So we go after you generate, sometimes you might repeat some trees that are not necessary. So we carry out tree pruning. that might have maybe some repetition unknowingly or mistakenly. We identify and remove branches that reflect noise or outliers. Sometimes, like in the samples also could have outliers, they could have noise samples that are not correct, that could it could actually confuse the decision tree we are building. In that case, after finishing with the building, we can try to do what we call tree pruning. So we can deal with this one later. Let's start with something simple first. Now, after you build your decision tree, then you can then use the decision tree finally, which is now, it's like you want to test what you have built to be sure it is working fine. That is by classifying an unknown sample. You test the attribute value of the sample against the decision tree. So once we finish building this decision tree, we are sure this is the decision tree, we just pick a new sample and we use that particular decision tree to classify it into the correct class. Now we're going to use this our example now fully to solve a problem and see how we can deal with it. Now, so looking at the example, let's quickly see. This is our decision tree we built. We built this decision tree. I've explained how we did that. Now, the basic algorithm that we usually utilize, which is the basic algorithm of decision tree, which is known as the greedy algorithm. Here, the tree is constructed in a top-down recursive divide and conquer. So whereby all the training examples are the roots. I've explained this. Attributes are categorical. If your attribute is continuous value, you have to discretize it in advance. Maybe you have age. You have a value, maybe the age is like 70, you have 70 there, 20 there. You have to discretize them. You see? Okay, age that is less than 70, you deal with them. Greater than 70 or less than or equal to 70. Because this is decision. You have to make a decision at every node. So you cannot just say age 70. How many people will be age 70? So you use decision symbols to break them down into discretes. Now, then, so once you've done this, then examples are partitioned recursively based on selected attributes. And then the test attributes are selected on the basis of heuristic or statistical measure. Example is the one we call information gain. And also we put the condition for stopping partitioning. The condition to stop the partitioning will be given. These three conditions are very important. So we'll do more with them as we proceed, inshallah. One, you stop when all samples for a given node belong to the same class. When all samples for a given node belong to the same class, you stop. That is a particular node, all the samples there, they are on the same class. Yes, you don't need to do anything there. Then, two, there are no remaining attributes for further partitioning. Sometimes also we will stop when we finish using all the samples that we have. So there's no more samples to be used, so we stop. Then sometimes majority voting is employed for classifying the lead. So when you don't have any other attribute to use, then you have to take a decision. See? So the attribute got finished. However, in one of the nodes, we still have samples that are either yes or no. So in that case, we have to categorize them based on majority voting. Okay, what is majority? Where do we put one to? Where do we put this to? Or another way is there are no more samples left. These are some of the common three conditions for stopping your recursive divide and conquer on the decision tree. Because like I said, decision tree is one of the very, very popular methods being used across boards because of the divide and conquer idea. When you divide the problem into two, it becomes very easier for you to solve the remaining ones. You divide that one again to two, and then later you can combine your results together. So you keep doing that until either in a particular node, all samples are the same class, or the attribute you are using got finished. Since you cannot repeat the attribute again, so you have to stop. Then those ones that are yet to be classified, then you have to classify them using majority voting, or you also stop if there are no more samples left. All the samples we want to classify, they are already successfully classified. So at that point, we have to stop the algorithm for it. Now we are going to have, let's have a time. Yeah. Now, hello? Yeah. Yeah, at least I can see some hands up, so you can ask questions because of our time.
I'm not very sorry for.
It's okay, go
My
ahead.
question is on the discrete of a thing. I don't know if it is allowed for the issue of probably like saying age between 16 and 70 will such be tolerated.
What I said was, as you can see in the example, yeah. So we're still going to deal with the example now. We are having it here. Now, you can see it here. We are going to demonstrate in this example. They were not sure if we can do that today because of time, maybe next time. You can see here, this is an attribute. This one is easier for you to do directly. Yes, no, yes, no. You see? However, when you, this is a number that this is categorical values. So we can easily say that, okay, refund. Did you refund? Yes, refunded or no? But when you have numbers like this, we say you have to discretize. When you have continuous value, you have to do discretization. Discretize, you are going to see here, look at the example here. So in which case, we have to deal with, okay, since here we are selecting, if the refund is yes, you can see we are going to select this guy, we select this guy, we select this guy. If it is no, you have other people also that are qualified in that direction. However, for the case of number, then you have to select a discrete, a particular range. So here now they are saying that less than 80K or greater than 80K. This is less than or equal to 80K or greater than 80K. Because this is the only way you can group people together. This is the idea of discretization. See, when you have continuous number for people, this is taxable income, 125K, 100K, 70K, and a host of others. But decision tree means at every node, we need to take a decision. So that's why you cannot just say 120. You see, that, okay, I want it is equal to 120. Okay, what other people? Is only one person, maybe only one person will be affected. That's why we have a we discretize this. At this level, when I say less than or equal to 80K or greater than 80K, you have many people who will fall into this category. Why many people also will be in this category? So that was the idea of discretization that I mentioned, and we are going to see it practically as we move on.